Science Department. And with me is Megan Potter, one of our senior advisors in the department. Welcome, and again, congratulations. This first slide is shows you a picture of the dean's office. Dean Kurt Brenneman is the second from the left in this picture, and to Associate Dean Sibel Adali just to the right of him, and Lee Ligon to the far right. This presentation is a mixture of material about the School of Science in general and computer science in specific. So we will start with the more general material and then focus in on the department. One thing you should note is there's some very important events will happen during your time at Rensselaer. We will begin our 3rd century of existence. We are the oldest technological university in the country, and there will be a total eclipse of the sun. Okay, I'm having a little bit of difficulty here with the slides. I have to control the slides. There we go. All right, so the first thing is about the people at Rensselaer. And the first and perhaps most important thing is the strong students. You are one of them. If you look at the current statistics on the accepted students, an impressive 1,455 SAT score average, 74% in your top 10, and 37% identify as female. We're hoping you will join our 1,900 undergraduate students, and there is also well over 300 graduate students. One of the things you come to Rensselaer for is the quality of the students around you. You're going to meet some amazing people, and those people will help, as we say, change the world, but they'll also help change you. And they will have an impact on you for the rest of your life, and you will have a positive impact on them. The students are guided by an amazing faculty. Here are 9 of the faculty members in computer science. Starting in the upper left is Professor Barb Cutler, who is a graphics expert and also leads the Submiti project, which is a student software effort, which we will talk about a little bit later. Next to her is Professor Carlos Varela, who's an expert on cyber-physical systems. George Slota, who is an expert on very, very large-scale graphs. Larong Cha, who is an expert on AI and social computing online. Moving to the bottom right, Stacy Patterson, who does work in the Internet of Things, distributed control, and now is interested in quantum computing. Jiangxi Gao, who is one of the leaders in network resilience. In the center there is Anna Milanova, who is an expert on program verification, and in particular is interested, has developed techniques to detect tampering in apps. Just second from the left, at the bottom is Alex Gittens, who's an expert on machine learning and especially optimization methods. And yours truly is in the lower left. I'm interested in computer vision and in particular applications in biology and ecology. If you look at the School of Science as a whole, you will see that we have a wide range of specialties. And these aren't just in the departments, but there are many of them across departments. So for example, biochemistry and biophysics. We have environmental science, which crosses geology, biology, and chemistry. Astrobiology, which involves a number of departments, excuse me. And they're very interested, of course, in the new Mars rover, as well as problems in extreme environments. And again, we'll talk about that soon. When looking at colleges, it's very common to ask the question, what do the alumni do? What is my return on investment? So here's a snapshot of our recent graduates. About half of them employed secured jobs after graduating, and about half of them went to graduate school, and a small percent, we're proud to say, were dedicated and have joined the military. We're not proud of the small percent. We're proud of the students who actually did join the military. About a third of the students completed research for pay or credit. About a third of the students completed an internship or co-op experience. We like to talk about the $81,000 median starting salary, but then we talk about computer science and we look at our median starting salary and we're over $96,000. That's a big return on investment. Finally, you can see in some of the list of some of the places that our amazing students go. Amazon is a big employer, Boeing, UC Berkeley, ExxonMobil, Microsoft, pretty much all of the major software companies, as well as the financial services companies, and many students actually start companies themselves. We even have a few astronaut alumni. Our programs are built around the 6 departments in the School of Science: biology, physics, chemistry, computer science, earth and environmental science, and math. And we also have an interdisciplinary program in information technology and web science. So let me talk about that for just a minute. So ITWS is information technology and web science, as I said. It can be thought of as a more applied and business-focused view on the field of information technology than the more technical and theoretical and software-focused work in computer science. So it's a highly ranked program. It was ranked #1 several years ago by the collegechoice.net and focuses on applications, data science. And if you're interested in looking at the comparison between computer science and and ITWS, we will have a special program later in March, and we'll provide details on that soon. We also have innovative pedagogy, pioneering many new methods, and so I'm going to talk about each of these. The first one is a Bridge Scholar program, where students who might want a little bit slower on-ramp come to join us for 6 weeks during the summer before their freshman year, their first year. It was piloted in calculus and physics, and we're going to start it, we hope, in computer science this coming summer. The idea would be 2 weeks of intensive effort. It will be virtual, but it will be 2 weeks of intensive coursework, followed by 4 weeks working at a steady pace on projects at home. So that's something that will be available to apply for later in the spring. We also have a strong mentoring program. The iPersist mentors are calculus and physics, and computer science has a strong mentoring program as well. These are students who are near peers. We hire students as early as their second semester freshman year. They participate in labs and office hours and help coach students in their addressing their homework problems and learning the material in computer science, and really just providing encouragement and guidance as student faces the challenges of our curriculum. And finally, I promised a discussion of Submiti. Submiti was the project led by Professor Barb Cutler. It is an open source software system for homework submission, online course discussion, grading, testing, and we've introduced many innovations for using it for online courses during the pandemic. We're very proud of the effort, and many, many students have contributed to this software. There's much more than just your core material in your curriculum, so we want to stress some of those here. The first one is there are dual majors, which is where you satisfy the degree requirements for 2 majors. So you would receive a diploma that lists both of them. Now, this is different from a double major, which is actually a double degree. In this case, you get 1 bachelor's degree within the same number of credits that has 2 majors listed. A double major, which is really a double degree, you have to take, I believe, 32 more credits, and you get 2 Bachelor of Science degrees. Computer science has about 1/3 of our students are dual majors, with the most common one being mathematical sciences, but there are many others, including electrical and computer engineering, psychology, cognitive science, ITWS is a common dual major, and many more. We also have the opportunity to do minors, which is usually 4 or 5 focus courses within a discipline. There's also a coterminal Bachelor of Science and Master of Science program where you earn a bachelor's and a master's within 5 years, and your financial aid continues for the 5th year. This is what we actually recommend. If a student has enough credits and wants to do a double degree, we actually recommend that they do a master's and a bachelor's together instead of the 2 bachelor's degrees. We have a strong coterminal program in computer science with about 20 to 30 students a year. There's a heavy involvement of research on campus with undergraduates participating. As you saw, about 1/3 of the students participate. This happens during the academic year as well as the summer. Computer science students are particularly in demand. There are projects within computer science, but also in many disciplines. And often the simplest thing is to start out writing software to support the project, but usually very often students become modelers and contribute to the actual design and analysis in addition to also writing software. Co-ops and internships are a very important part of computer science curriculum. They're not required, but many students participate. And the idea is you spend a semester or a semester and a summer getting practical experience with a company, and of course you get paid for it quite handsomely. There's a strong emphasis on entrepreneurship as well, often working with the business school. And I have to brag that we've had several startups come out of our graduating seniors, including one who's working on online classroom software, and they've gotten $1 million in venture funding already. And then students many students do participate in international studies as well. So I mentioned briefly the Arch. The Arch is a summer junior program on campus. It's the summer after your sophomore year. Students during the Arch, the first semester juniors are the only students on campus, or the only undergraduates on campus. There are special courses. You get to experience the area in the summer activities and have a more focused interaction with your faculty. And it's really a transition semester. And it's followed by an away semester during either the fall semester or the spring of your next year, your junior year. And a lot of it is focused around co-ops and internships for computer science students. But there's also study abroad. Students work on their startup companies or as professional software developers. And there's also service projects. And so you can see some of the activities. There's the Saratoga Jazz Festival, usually in late June. There's a lot of hiking in the area, as well as, for example, whitewater rafting. Lots of opportunities. Rensselaer's research is focused on many global challenges, and there's a heavy involvement in computer science in all of these. There's a lot of work on materials science and modern materials, often designed using machine learning and software methods. We're heavily involved in renewable energy. And of course, there's a lot of work into artificial intelligence and machine learning. And in particular, we have one of the world's fastest supercomputers. It's called AMOS. The abbreviation is given there, but it's really a pun on the name Amos Eaton, who was our first professor at Rensselaer, and half the department is in the Amos Eaton building. If you don't understand what this 252 units with 2 20-core Power 9 processors and 6 NVIDIA Voltage GPUs, just understand that it's a very powerful system for machine learning, AI, distributed computation, equation solving, and undergraduates get access to this through their research and courses. So students in my spring course in computer vision will be doing 2 of their assignments on AMOS, and my fall course, which will be on semi-supervised learning, we will also make heavy use of AMOS. And it has been widely used outside of Rensselaer for research related to COVID, including vaccine designs. One of the unique projects at Rensselaer that computer scientists are involved in as well is the Jefferson Project. Now, Lake George is about 45 miles north of campus. It's been described as one of the most beautiful lakes in the world. It's clean. There are very few invasive species, and there's a serious effort to instrument the lake, keep track of its health, and also monitor for invasive species. The Jefferson Project is a partnership of IBM, Rensselaer, and the Lake George, the Fund to Protect Lake George. And you can see the Jefferson Project site in Bolton Landing in the upper left. As I mentioned earlier, there's Rensselaer Astrobiology Research and Education Center led by Professor Karen Rogers. It is interested in both origins of life and potential life on all outside the Earth, as well as life in extreme environments. And that is the specialty of Professor Rogers' research, and she recently won a major NSF award to lead this center. Now, focusing specifically on computer science, we'll start with the degree program. There are 8 named courses, the 2 introductory courses in your first year, 4 in your second year, including software systems, a couple of theory courses, as well as computer organization. Then there's 2 more in your junior, senior year on programming languages and on operating systems. There are also 4 option courses or capstone courses involved. 3 of them have to be in one of our concentrations. Those concentrations are AI and data are 1. Theory is another. Graphics and computer vision or robotics are a 3rd. And software systems are the 4th. And you have to take 3 of your option courses in one of those areas. There's a science core as well that involves 4 math classes, 2 of which have to be calculus 1 and 2, and 3 science courses, 1 of which is physics and the other is biology. And the other courses, the other 2 math courses and 1 science course, have a substantial amount of flexibility. There's also 6 required courses in humanities, 24 credits, and they have to be distributed across humanities and social sciences, and there's concentration requirements as well. In addition, there's 6 credits of 6 courses of free electives, and this is where students opt to pick up a dual major, for example, or pick up a minor. And when you do a dual major, what you're really doing is fulfilling the additional requirements over and above your computer science requirements to satisfy the major. And that is why with math, with already having required 4 courses, taking an additional 6 is relatively straightforward. Of course, intellectually challenging, but programmatically is straightforward to do to get a dual major in math, and similarly in other areas as well. There are communication requirements, 1 in humanities and arts and social science, and 1 in computer science, bringing us to a total of 128 credits, which nicely works out to 4 credits or 4 courses a semester for 4 years. The one thing I really, really want to stress about the computer science department is we want our students to get involved. We have a very strong center and club system that I really would like to talk to you about now. It is how you meet people. It's how you collaborate with other students and learn from other students and really build your resume. The first one and the biggest one is the Rensselaer Center for Open Source Software. It was funded by alumni Sean Sullivan about 12 or 14 years ago. And students either participate in an existing project, one that previous students have developed, they join a large-scale open source project outside of Rensselaer, or they propose their own. We've had some funding from SMITI from Google Summer of Code. We have scheduling software, Yaks and Quacks. SMITI is a big, probably the biggest project. And we have also things like venue, bus scheduling, bus tracking, and a lot of other sort of social responsible. There's 150 to students a semester participate, some for credit, some just for the experience, and have done some amazing projects. And the other thing is that there's a strong leadership opportunity for all students, and its leadership is strongly encouraged. Let's see. Did I miss one? I missed two. Nope. Sorry. Next one is the Association for Computing Machinery Women's Chapter. We have a strong women's group. They have professional development programs, peer mentoring, faculty mentoring. They interact a lot with our faculty, and also participate in conferences like the Grace Hopper Celebration of Women in Computing. And you can see pictures on the upper right taken from the 2019 Grace Hopper, and we were able to have at least 40 participate virtually in the 2020 program. Very strong group of individuals, and they will have their own separate panel discussion in March, as well as an Instagram takeover. We have a world-renowned security club, RPISEC. They've placed in many international capture the flag competitions, winning things as silly as basketballs and as serious as $10,000 checks. It's also interesting that our students at these competitions get offered jobs on the spot. RPISEC is also known for some introductory course material that they've developed that's used throughout the world. And they've also interacted with our faculty to develop a modern binary exploitation course. One of the very important things about RPISEC is you can join your first day at Rensselaer and you do not have to have any experience. They welcome new students and want you to get involved. And this is true, of course, of every club. We have a strong hackathon group. It's been running for about 8 or 10 years. It is student run, entirely student run. And every year the leadership turns over, with the junior leadership becoming the senior leadership and the senior leadership becoming advising roles. We have first year students become leaders. And again, it's a way of getting participation. To participate, you do not ever have to have written code to participate in your first semester. We had over 350 in our virtual hackathon in November. We're hoping to be in person next fall, but it's likely that we will still have a virtual component at that time. And it is, of course, great for recruiting and internships. And you can see a list of some of the companies who have participated: Bloomberg, TripAdvisor, a local healthcare organization, and even Google's TensorFlow and Palantir. So lots and lots of opportunities to learn, to write and develop new cool things, and also to get internships. And if you don't know what it is, what a hackathon is, it's a 24-hour programming event where you come in with an idea. You cannot have written any code in advance, and you sell your idea to try to form groups with 3 or 4 other students, and you just do the best you can to build a prototype in 24 hours. And there are tutorials, there's coaching, there's opportunities to meet people from companies, often alums. It's a great experience, and for many students, it's one of the highlights of their academic career or non-AC classroom careers. We also give back to the community. One of the biggest organizations is Coding in Community, and it was started by Melina Gonzalez, who has now turned it over to younger leadership. And the idea is to teach the basics of programming to underserved population. They participated in both local events with weekly meetings at the Troy Middle and High Schools, as well as some statewide STEP program students. Finally, we have an honor society called Upsilon Pi Epsilon. You can join as early as your sophomore year after you've successfully completed our Introduction to Algorithms class. Tech talks, programming competitions. They have their own meeting space and they work there frequently. And it's also right next to our new student work area in the Amos Eaton building. There's a strong connection with alumni, and that's actually true of other clubs as well, including Hack RPI, RPI Security Club especially, as well as ACMW. And we've had fun faculty competitions on editors who could write the program in an editor faster, or computer science trivia. And the students have yet to beat the faculty on this one. The last thing, and the thing that's not mentioned here, is UPE also runs a tutoring, and there's tutoring run by the other clubs as well. So in summary, and this applies to both the School of Science and Computer Science, our goal is to have an impact. We have excellent faculty. We focus on global challenges. We involve outstanding students of all backgrounds, prior training, and they're training using the latest methods. We have state-of-the-art facilities and strategic partners with companies like IBM. So come join us, be part of the great team of students, and do awesome things. I'm perpetually amazed by what the students do. I've been here for 32 years, and I'm never tired of the incredible things that our students do. It just amazes me every year. And every year we have wonderful student leaders who graduate and move on, and we worry, and the next moment we almost forget about them because there's another crop of amazing students stepping up to lead. Will you be one of them? We sure hope so. So here's a summary of events. There's a meet and greet in another couple hours, and there will be current computer science students as well as some information technology and web science students. And I think at least one of them is a dual major in those disciplines. Throughout March, here are some of the events. There's the student webinar, which is in 3 weeks. There's a Women in Computer Science webinar in late March. And then starting on the 22nd and running through the end of April, we will have weekly Meet a Professor events. And they're listed on all of these are listed on our computer science department website. And there will be many more events posted there that you can sign up for and participate, including more meet and greet student sessions with other students. At this point, I'd be very happy to stop and answer questions. I've seen a bunch of them come by, and maybe Megan can join in on the broadcast and help me sort through some of the questions. So this is Megan Potter, who I introduced earlier.
Hi, everyone. I've been answering some of the questions that have come through the chat. Haven't gotten to everyone, but let's see. Chuck, we've gotten some questions about dual majors, such as math and physics. Do you want to speak to the dual major process at all?
So you come in to Rensselaer as assigned to a major. So most of you would come as a computer science students. I assume that's why you're here, and we'd love to have you. And then as early as your second semester freshman year, you can declare a dual major, what you do is you get the templates for both majors, and you take courses to fulfill both templates. That does not mean, for example, if math says you have to take 4 sciences and computer science says you have to take 3, it does not mean you have to take 7. You have to take the union of the requirements, which would be 4. So you basically just have to have on your transcript fulfillment of the requirements of each of the majors. You can use the same course to fulfill requirements of both majors. One example in computer science is graph theory, and graph theory is offered cross-listed as math and computer science, and it can count toward both. Similarly, some of the advanced computer science courses also count toward the ECSE major, or the computer and systems engineering major. But the key idea is when you are ready, you would fill out a form, declare that I'm going to do this dual major. You would get assigned a second advisor, one in that department. You would meet with those advisors once a semester if you wish, once a year is required, and more if you need it. and then you simply fulfill the requirements of both majors. It is easy to do in computers with math, with pretty much any other department. I think ITWS and math are our two most common. We have them with psychology, economics, business, philosophy, cognitive science, every major in the School of Science, electrical and computer and systems engineering. There are even students who do it with chemical engineering and mechanical engineering. That's a little harder, mostly because the curriculum is very well laid out, and there's not a lot of options. So students in some of the engineering disciplines have to take course overloads. But in general, you do not have to take overloads to fulfill the requirements for a dual degree, a dual major. Other things.
Let's see. We got a question about, is there a CS placement
Good question.
test?
Yeah. Okay. So we have our freshman first year courses are Computer Science 1 and Data Structures. About half the students start in CS1 and about half the students start in Data Structures. The regular template that you will see has CS1 in the first semester and Data Structures in the second. So I think the main question is, how do you know where to start? We do not require a test. We do not require AP. It is really where you are comfortable and ready to start. So if you have a lot of programming experience and you're confident and you want to really move ahead as quickly as possible, you would start in Data Structures. If you'd like to kind of go back and review, or maybe you haven't programmed in Python before, then you would potentially start in CS1. We've had students who with AP credit start in CS1 anyway. You just can't get your AP credit if you start in CS1. We've also seen students without AP credit start in Data Structures and do just great. And it also doesn't matter in terms of how well you do in the major, how well you do in becoming a student leader. We get students from starting in both CS1 and starting in Data Structures. The other thing is you've got about 4 weeks during the semester to make a switch between the two. We have students who start out in CS1 and say, maybe look at Data Structures and say, no, wait a second, I'm ready to do that. Or we have students who start out in Data Structures and say, maybe I'd like a bit slower introduction and then come back and take Data Structure second semester. So it is very flexible. You can meet with advisors, you can meet with the faculty, and you can change all the way up through pretty much the first month of the semester. Very flexible.
Okay, let's see. Are students able to take CS major core courses in their freshman year?
CS major core courses, yes, but only through sophomore courses. We generally don't allow placement beyond Data Structures. So and this comes from, unless you transfer in an accepted Data Structures course. Our Data Structures course is challenging, and it's where students really transition from writing small programs to writing computer science programs where they've analyzed a problem and implement a challenging algorithm or data structures. So we generally do not allow placement beyond Data Structures. But if you do take Data Structures your first semester, in your second semester, you can take Computer Organization and Foundations of Computer Science, which would put you into the beginning of your sophomore, or push you halfway through your sophomore year in the core requirements. We do not generally allow first year students to take junior, senior level courses. There are very, very rare exceptions. But I think most students will find our curriculum sufficiently challenging, as well as very important educational experience. So we really focus on putting our first year students, our first semester students in either CS1 or data structures. Happy to answer follow-up questions, so please keep posting.
We also got a question about, do CS students commonly use Mac or Windows devices for their projects? And is there a better option?
It is
or is
100% based on preference. Very much so. The student issued or the school issued laptop is a, I'm drawing a blank, is a Windows machine. It's a Lenovo, is that right?
I think so.
And they're powerful machines. They, so students will use those. Often students will either will just use that, or they'll add the Linux-like tools, or they'll even add a second operating system. But even that's gone away somewhat with virtualization, which you'll learn about, where students' entire course will be inside of a virtual machine. I'm a Mac person. Often students just run Linux as well, and you don't have to really prefer one or the other. It's really whatever is, or you don't have to feel any need to choose one or the other than your own preference.